So, let's think about all that we know for this problem. So I wrote down the rate that I know. Actually, that's right here. The rate that I know. I wrote down what I want to know, and I wrote down when I want to know it. Um, I wrote down what I my notation, what that means, and water leaking onto the floor in a circular pool. Ooh, I know stuff about circles. And we're talking about area, so maybe I need to have the area of a circle. That would be area equals pi r squared. Area of a circle. And well, it's asking. Well, it's asking how fast. All right. So how the heck do I? It's asking for this. That's what the question is asking for. How the heck am I supposed to get a dAdt if I only have an a, or a drdt when I only have an r squared? Well, my friends, you just take the derivative. It's very easy from this point onward. If you understand all of how to set this up, then you're golden. You're golden. Except for, I mean, your organs still work. I said figuratively, you're golden. Not literally, because you would be dead. Like the guy in Game of Thrones. Anyway, if I took my area formula, r squared, there we go, and I took the derivative with respect to time of the whole thing, well, remember, these disagree, so I have to use implicit differentiation. The derivative of a, like normal, is just 1. And then I tack on a dA dt. Oh, very nice, very nice. That's what I want to know. And then here, pi is simply a coefficient. So I'm thinking about the derivative of r squared, like normal. Well, the pi stays out front. I'll put that down, take that down to r, right? And then, because they disagree, I tack on a dr dt. And there we go. And I'll clean it up a little bit for your faces, so for your eye marbles to see. And you have 2 pi times r dr dt. Now what the heck? I wanted numbers for that. What's going on? Well, just look at this, Captain Hook. Looky here. R is 5. Look at that. They tell us everything. They tell us everything. Find dAdt when r is 5. We already know drdt is a constant rate, and it's 4. So this is 4, and it's actually centimeters per minute. And this is 5 minutes. No, 5 centimeters. It's a radius. That makes sense. 5 centimeters. So, we have dAdt. I'm just plugging stuff in. It's just as simple. 2 pi times 5 centimeters times 4 centimeters per minute. And look at what centimeters times centimeters is centimeters squared. So what do we get? 2 times 5 times 4. What is that? 1040? 1040? No, it's 40 pi centimeters squared per minute. Isn't that wonderful? That's how fast the area is changing. Oh, it's beautiful, guys. It's beautiful. Well, what's 4 pi? That's like 4 times. That's roughly 120 centimeters squared per minute. That's how fast the area of the pool is. You get it bigger. So there we go. The rate at which the area is changing. This is the exact answer, and this is the approximate answer if you multiplied it out to 3 decimal places, or rounding to 3 decimal places. And that's all that they're asking. Hopefully that makes sense. What were the steps that we used? Well, we wrote down the notation for the rates that were given and desired. This is optional to write down. Maybe you should. I think it's a good idea for you to listen and write it down rather than me actually writing it down. Maybe it makes you think more, and maybe it makes me have to write less. Maybe. But so the first thing that we did was wrote down the notation for the rates that were given and the rates that were desired, the rates that we wanted. So that was that red part right there. That was this red part. If you need me to say it again, just rewind it. It's a video. Duh. So after that, we wrote down the value of the rates that were given. We wrote down the rate that we needed with a little question mark to signify that we don't know what it is. We want to know what it is. And the when. We have to write down the when. We need a when. So when r is 5. In the more difficult problems, we'll have to figure that part out, but we'll get there. So write down the notation for the rates given and desired, the actual value of the rate given. Write down, somehow signify that you want to know, you don't know, but you want to know one of the rates, and write down the when. When do you want to know about this rate? The next thing we did was tried to find some equation. The equation that you take the derivative of, I'm going to call that the primary equation. So find your primary equation, and then in parentheses, the equation that you're going to take the derivative of. And the hint here was that they talked about a circular pool, and they talked about the area. And I knew the area involved a radius and an area, so there we go. So that's writing down the primary equation from the information given. And the primary equation, once again, is the equation that you're going to take the derivative of. And then to get an equation that relates your rates, related rates, that's what it means. To find an equation that relates your rates, you take the derivative of your primary equation. And then we plugged in stuff and simplified. Oh, it's beautiful. It's super beautiful. It's like I don't know, things that it's like a pet flowers, like flowers. I don't know. We definitely should see more examples.